Okay, I'm back, and now we want to talk about what are some of the products of volcanism. So, in other words, what comes out of volcanoes. So, one thing is going to be lava, and you have different kinds of lava because they have different chemical compositions. So, the first kind of lava that we want to talk about is going to be basaltic lava. And so, these lavas are going to be very mafic in their composition. So mafic mafic lavas tend to have very little silica. So if you recall from a previous lesson, we talked about Bowen's reaction series, and we said that the mafic lavas are going to have a lot of olivine and amphibole and pyroxene in them, but very little silica. So that means that they're going to have low viscosity, and then that means they're going to be very runny, and so their kinds of eruptions are going to be very gentle. And so you're going to have stuff that might spray into the air. You might have some stuff that's going to run on the ground, but normally they're not going to be very explosive. So examples of this would be in the Hawaiian Islands. Okay, another thing that you could have is lava tubes, so that the surrounding material is going to cool off faster than what the magma is going to. And so what you end up with is these hollowed out tubes where the lava used to be. Another one is you have specific kinds of igneous rocks that result from the solidification of the lava. And so one is called pahoehoe and one is called aa. And so the pahoehoe makes very ropey, not jagged, igneous rocks, and so it's easy to walk on it. And then the aa, which you can guess where that word comes from, is very jagged pieces of basaltic lava that has hardened into igneous rocks. You also have pillow basalts. So this is what's going to happen when the basaltic lava encounters water. So like it pours into an ocean, then it's going to make these kind of pillowy looking lava flows. And if you recall, we mentioned that when we talked about at mid-ocean ridges where lava comes to the surface and it makes these pillow basalts on the surface of the ocean floor. Another thing about basaltic lava, when it hardens, it makes the basalt tend to crack into columnar jointing. So these joints run up and down, and then if you were to look down on the top of it, you would see that it makes hexagons. And then, so as this material is cooling off, it contracts, and then as it contracts, it makes these particular patterns that we call columnar jointing. All right, now let's talk about andesitic lava flows. So these are going to have more silica in them, and so that means that they're going to be more viscous, which means that they're going to be slower. They're not going to be runny like the basaltic lava was. And so they tend to mound up around the entrance to the volcano, and they do move, but they move a lot slower. They tend to mound up, and they tend to make more blocky lavas. So instead of the ropey lavas, the pillow lavas, these are going to tend to make more blocks of lava. And then as more lava is coming up behind it, those big chunks of lava then can tumble down the sides of the volcano. Okay, then you can also have lava that has a rhyolitic. And so now this is going to be composed of quartz and feldspars and micas. And so this has the most amount of silica in it. So this is going to be the most viscous of the different kinds of lava flows. They're going to flow the slowest, if at all. And so what they tend to do is make domes, so that this material just causes the ground to rise and to make a dome, and then occasionally some of this material might tumble out of it, but not very far. So these rhyolitic lavas do not tend to move very far from the volcanic vent where they're coming out. So they're going to be the slowest. So you end up with your domes, and then another thing that you can end up with is another feature is going to be called a spire. And so those are produced by rhyolitic lava flows. All right, let's take a break, and when we come back, we're going to talk about what do volcanic gases and aerosols do.